Hey guys, my name is Maggie Desai, and this is a video I'm going to explain you what is electrical engineering and different subdivisions of electrical engineering. So what is electrical engineering? Electrical engineering deals with the engineering of electricity and electromagnetisms. Starting off, electrical engineering has 6 subdivisions: power, controls, electronics, signals and systems, that is signals and processing, communications, computers. So starting with power. Power is something that deals with physics and maths heavily. So, as a power engineer, what does it mean? It means you did electrical engineering, but your concentration, your observation, in most of the case, your learning was revolved around power. What is power? Power is P equals VI, but what do power engineers actually do? They work with generation, transmission, and distribution of power. So, for example, if I have a solar plant or a wind farm or like a traditional power plant with coal, what if I'm producing, let's say, 200 megawatts of power? I'm generating that much power, so I would be working with motors, generators, transformers, and all the other sorts of things. And the other part would be for me to send that power to the grid back itself, so it can distribute it to different subdivisions of the locale. So what is the other part? Transmission and distribution. Transmission and distribution people, they look at different power plants in a one big picture. So not only my power plant, they also look at 3 others that are right next to me that I can't see. Like, I can't see their working, I can't see their output, I can't see the problem that might cause, that might affect me if they go out. So that's what transmission planners basically plan the transmission. So they basically provide a route. So they're kind of like the traffic signal. They provide you a route, or like GPS coordinates. They provide you a route to go from one place to another. So they tell me, okay, you have to send this much power to here, while distribution takes care of distributing power equally, so they're not doing any bias. Transmission planners are the ones that are looking 10 years into the future and thinking like, okay, what if we take out this power plant, and what if we put that power plant here? How does it change? How does the system change? While distribution power planners care about is each and every one receiving enough power to supply their load. So if I'm supplying a subdivision, but I'm only generating 200 megawatts and my load is 200 megawatts, transmission planners might tell me like, oh, please send some of your power to that to the load that is connected to the other power plant, just because it was because of some reason. But what distributions would do is make sure that I don't lack power to supply my own load, because if I'm lacking power, that is of no use to transfer that much power into the other one, when I can just use all 200 to supply my load. Simple. As simple as that. So moving on, controls. What do controls engineers do? Controls engineer, I'll explain it with an example. So, for example, if you were to design a robot that looks up at this keychain and sees like, oh, it's this keychain, I want to put that keychain on my left. You can have 20 different things in front of that robot, but all that robot should care is about this keychain, not about this balloon sticking out, not about this water bottle, nothing else. All it should look for is the keychain. So as soon as the robot sees the keychain, instantly the brain of the robot should tell the robot to pick it up, put it on the left side. If it's not doing that, that means there is a problem in your control system. Control system is designing the brain of your robot, or brain of your machine. So controls engineers work with automobiles, they work with aircrafts, they work with all sorts of things. They basically design the board. They basically design the brain that goes into a machine. It's very heavily math inclined, and it also requires coding. It also requires you to know machine learning. So not all electrical engineers work in a power plant. So now moving on to electronics. What is electronics? Electronics is electronics requires you to design electrical circuits. starting so like microprocessor design, or like microelectronics. Nanoelectronics is a big hit right now. They all fall under electronics. As an electronics engineer, your main task would be to design a circuit that produces certain output. So, for example, I had to design a project. I had to design a power circuit that would give an output of 12 watts. I'm designing that circuit. That means I'm doing electronics. So, even design of this chip that is inside my keychain, yes, falls under electronics, because I'm taking different components such as resistor, capacitors, and everything, and putting them in a working drawing. That is electronics. Basically, design of your cell phone or the chip that goes inside your cell phone. When they talk about i4, i7, what makes them different is the IC chip, the main IC chip that goes, different IC chips that goes in that iPhone. That's what makes it different. And right now there is a lot of boom and bust in electronics, because I think electronics will always be an evergreen field of electronics, but it also means it's one of the most hardest fields, because you have to take into account, look how small this chip is and look how many devices are in here. You not only have to make this chip smaller, and it has to look pleasant. It doesn't have to look like, oh, someone just threw up on it. No. It has to look smaller, it has to look prettier, it has to be very effective. If it's small but it can't do the work, there's no point in producing it small. Might as well just stick with the large. Okay? So they work with Intel, National Semiconductors, or even like, what was the place name? I don't know, soft filter designs, like you're designing something, those kind of things. And then there's signal processing. Signal processing is where you are working with signals. So for example, my speech is a signal. What a signal engineer would care is how to change the signal in such a way that when it's transmitted, you receive the exact same signal. There is no loss whatsoever. So it's kind of like your packet servicing. So whenever Amazon sends something, Amazon makes it sure that it's the same thing that you ordered. If you get someone else's, that means you have to return back, and that creates a lot of problems. Same thing for signals engineers. They don't care how are they transferred. They just care about what is transferred. That's the most basic thing. And signal processing people usually work heavily with communications. They work with radio frequency, and they use things like amplitude modulation, frequency modulation. Like in antenna design, you would need signal processing. Antenna is something that takes in a signal and transmits it, or receives it. If it's a transmitter, it will transmit. If it's a receiver, it'll receive. Doesn't matter. But that's what signal processors do. Communications people, on the other hand, they care about how the signal is transmitted. So, for example, if I say, what is electrical engineering, and I press the button and I press enter on the Google, that means I send a signal to my brain inside my computer, that is my CPU. I told them to send whatever bit string. My bit string was, what is electrical engineering? That was my input to my CPU, and the output should be the results that people have posted, including this video. So what a CPU would do is communicate over wirelessly with different devices, such as a router, then a network analyzer, then like a virtual network, and then to a Google Hub. That Google Hub would be like, okay, I have the information that you requested, I'm sending you now. So that all happens wirelessly. Communications expert know that wirelessly. If it doesn't work, they have to make it work. They basically design the communications of your system. So for the cell phone, what is the communication system in a cell phone? It's the antenna that's in the cell phone. What is the signal that you're sending in the cell phone? Is you calling. As soon as it hears like, oh, they're calling something, they activate the cell phone, the antenna, the communication system of the cell phone, and that antenna, that's the duty of the antenna to transmit whatever I'm saying to the other person. And the antenna that's in the other person's phone, the duty of that antenna is to demodulate and to drop the exact same information that I wanted it to drop. That is what a communications does. Communications people usually work with designing of telecommunications things like satellites, radios, and stuff like that. So they deal with a lot of radio frequency. Fun fact, radio frequency is a big hit. I myself hold a technician's license of radio frequency. That means I can actually operate and match. I can operate radios during hurricane. So if you didn't know, during hurricane, nothing else worked but amateur radio operations. Like whenever the Katrina happened in New Orleans, all the communication systems were down except for the radio communication. So if I have the technician's license, that means I'm allowed to operate a radio frequency. It's pretty cool once you get to know it. So moving on from communications is computers. Many people, many, I cannot stress out this point. Many people don't know computer engineering is nothing but electrical engineering with a concentration in computers. Our life revolves around computers so much that we just made a computer a different field itself. So at the start of engineering, there were three major fields: electrical engineering, civil, and mechanical engineering. Computers didn't exist until they were designed. What computer engineers do is basically take all the classes with electrical engineers. So if you are becoming a computer engineer, trust me, you will take classes like circuits 2, or like the maths that all the electrical engineers take, or the coding class, the most basic coding class like C++ or Java in your case. You would take all those classes, you will understand, you will be asked to know the concepts of electrical engineering, because what is a computer? It's basically an electrical device. The device that takes different electrical signals and transforms different behaviors. That is what a computer does. For a computer engineer, you would either be working with hardware or designing the hardware of the computer system, so designing the brain of the CPU. In that case, you would be working heavily with controls engineer. So that's it. That's all I have for you. Let me know if you guys like my video. I know there are a lot of videos out here for electrical engineering, but I'm typically a kind of person that I actually like when a person is talking to me instead of showing me pictures on PowerPoint. I'm not sure if you guys do, but please give me a thumbs up and let me know if you need any help. Thank you.